And I was wrong and sort of ignorant when I said that this wasn't separable, because V is not your variable of integration, T is. Okay? Or you get dq. Now if you put this over common denominator, you're going to have this times V minus Q all over V, right? So it's going to be V dq over approximately 0.11 V minus 5.4 Q equals dt. You're going to get a natural log of this. The V is going to be there as a constant. You're going to have a reciprocal of negative 5.4 as your integration, as your, well, you do a U substitution, right? And you're going to get everything that you get, okay? Now, since I made this blunder here, obviously your variable is T, your dependent variable, not V. So I was looking at it as if it was V because it's early in the morning or something, okay? So you have this or this. And that, again, also emphasizes the fact that you can do this as first order non-homogeneous in this. And I know that this has got to be an exponential solution approaching this, okay? Which is why I was thinking, why didn't it separate? Because that is the really simple way that you see when you have an exponential solution, okay? Or an exponential approach to some asymptote. So it's good to see these patterns, but you know that's a bit of a stretch when you first go through a differential equations course. But that's not going to be the case now when we change the conditions. So let's move on to the condition where you have the oscillating flow rate. And that's going to change just one thing in the equation, okay? But I suspect that's going to make the equation either very difficult or impossible to solve in closed form, but we'll see.